Hi everyone, what's up? This is the third part of the window function series, and in this part I will discuss lead and lag functions in detail using examples as well as interview questions and their answers. If you have not seen the part 1 and part 2, feel free to check them out as well. The link is in the I button as well as in the description. In the part 1 I discussed row number, rank and dense rank, while in the part 2 I discussed person rank, cumulative distribution and ntile. If you are new to my channel, here's a quick note. I post new videos every week in which I discuss data engineer interview experiences along with interview questions and answers. So please hit the subscribe button. It will help my channel grow and keep me motivated to keep making such informative videos, and also it's absolutely free. So what are analytical or value window functions? The value window functions in SQL are used to assign a value to a row from other rows. So as you can see, there are 5 types of value window functions: lag, lead, nth value, first value and last value. So as I said, in this video I will cover lag and lead. Let's check out the data set that I'm going to use. So as you can see, there is a sales data, and the link to this notebook as well as the sales data is in the description. It consists of order date, region, manager, salesman, item, units and unit price. So all the examples and interview question will be based out of this data only. So now let's get started with lag. So the lag function assigns value to each row that belongs to the previous row or whatever specified offset is before the current row. Let's check out the lag syntax now. Select star, then comma, lag, column name, offset, default, and we are going to understand what each of these mean. Over partition by column 1, order by column 2. So if you want to apply lag within a window, then you mention the partition by keyword, and the order by keyword tells us that which particular row will come at the top within that partition and which particular row will come at the bottom within that partition. And if you want to apply lag on the entire data, you can just remove the partition by clause. Now what does these 3 keywords mean? So the column name is the name of the column or an expression. So expression can be, let's say a column has integer value, so you can do col1, that is the name of the column, -1. So that will give you the result of this particular expression, and on top of that then you apply the lag. So here whatever value the expression col1 -1 will generate, that will be assigned to the lag column. Coming to offset, offset is an integer that tells us how many number of rows behind the current row the value will be fetched. Default offset is 1. So if offset is 1, then 1 row behind value will be fetched. If offset is set as 2, then 2 rows behind will look for the value. Finally, the last keyword is default. A default value is assigned if the offset goes beyond the first row. So null is assigned by default if we don't define a default value in the lag function. Example, if default is set as high, so when offset is also 1, so for the first row lag will be high. Why is this? Because there is no row previous to first row. So by default it should have been null, but because we have defined a default value, so now instead of null, high will be added to the lag column. Now let's check out an example. So example 1 is SQL lag function without a default value. So as you can see, I've written the lag function as follows, and I've only mentioned the column name on which I'm applying lag, and I've not mentioned any offset or any default. So if offset is not mentioned, by default it is 1. And if default value is not mentioned, then by default it will generate null. Let's check that out. So as you can see, after executing the query, this result is generated, and I said I'm applying lag on order date. So based on the order date, that is this one, as there are no order date before this row, so in the lag column null is added. While if I check the other records like record number 2, as you can see, for this particular record, the previous record's value is fetched, that is 2018-0106 is fetched and returned in the lag column. Same goes for the other one. So record number 3 has the value of order date of record number 2, that is 2018-01 and 23. So the first row shows null value for lag column because it does not have any previous rows. The second row contains previous row value in the lag column. It takes value from the previous row due to default offset value is 1. Now let's check out some more examples. So the example number 2 is SQL lag function with a default value. So again I'm writing select star, lag order date, and this time I've defined an offset which is equal to 1, and I've also mentioned a default value which is 2015-0101 over order by order date, and I'm doing it in ascending order. So the lowest order date will come at the top and the largest order date will go at the bottom. And because there is no partition by clause defined, so the entire data has been ordered. Now if we check out the first record, as you can see, the value of lag is 2015-0101, which is the default value. Why is this? Because there is no row previous to record 1. So by default, the default value has been assigned, and the rest of the functionality remains same. So as you can see, the second row contains the previous row value in the lag column, that is 2018-0106, which is of record 1. It takes value from the previous row. Why? Because the offset value is 1. Now let's move on to another example, and in this example what I'm doing is I'm applying offset value equal to 2 into the lag function. So as you can see, here is the query: select star lag, again order date, and offset equal to 2. Default value is 2015-0101, and again I'm not applying any partition by here and ordering the order date in ascending order. So let's check out the data. For record 1, that is the first record, you can see the lag value has default value which we have defined here. But this time the record 2 also has the default value. So why is that? Because every time for every record, lag will check 2 rows behind. For record 1, it is checking 2 rows behind, but because there are no rows before 1, so it returns the default value. Similarly, for record 2 also, it will check 2 rows behind. Now there is 1 row behind record 2, but there are not 2 rows behind record 2. So for record 2 as well, we are applying the default value. Now if we check the third particular record, there is a row which is 2 rows behind the third record. Which one is that? That is the record number 1. So that is why in the record 3, we have the value of record 1's order date, that is 2018-0106. So to conclude, the first and second row has default value instead of null because offset is 2 and there is no second row prior to them. The third row contains first row's value in the lag column. It takes value from second row prior to it. That's why first row's value was picked. Now let's check out some more examples. So by now I hope you got the basic understanding of how lag function works, but let's cover the last 2 examples as well. So example number 4 is SQL lag function with partition by clause. So as you can see, I've written select star lag order date, then I've given offset equal to 3. I've given default value as 2015-0101 over partition by region order by order date. So what it will do, within each region, it will apply the lag based on the ordering of the order date. Now let's check out how it works. So using partition by clause, lag will pick values from previous rows within a window or a partition. And this window is which one? The window of all the regions. Rest functionality remains same. First, second and third row has default value instead of null because offset is null. Offset is 3. So let's check them out. These are the first 3 records. So as you can see, we have default value in all these 3 records because the offset is 3 and we know there are no 3 rows prior to any of them. So that's why you can see 2015-0101. The fourth row contains first row's value in the lag column. It takes value from 3 rows prior to it. That's why first row's value was picked. So as you can see, this is the fourth row and it has the value of first row's order date, that is 2018-0123. I hope you understood how it is working. So this time, instead of ordering the entire data, because I've given the partition by clause, it is ordering all the records within each partition. Example, it is ordering all the records within central, then it is ordering all the records within east, and then applying the lag function. Let's check out the final example, which is example number 5, using expression instead of column name. So if you remember, in the starting of the video, I said that you can either use a column name or you can also use an expression. So in this example, instead of just using the column name, I'm applying this particular expression. What I'm doing, I am adding 1 day to the order date. By how I'm doing that? I'm using the date add function for it. And rest of the code remains same. So what I've done, select star lag, then date add, and inside date add, order date comma 1, which will add 1 day to the order date, as I said. then offset equal to 3, and default value is 2015 0101 over partition by region, order by order date as lag, which is the column name, and from sales data. So the first, second and third row has default value instead of null because offset is 3, and there are no third row prior to them. All rows starting from fourth row contains the outcome of the expression, that is order date 1 plus 1. So let's check that out. Here is the fourth row, and as you can see, this particular fourth row's lag column is supposed to have the order date value from the record 1, and the record 1 has 2018 0123. Now the expression is adding one date to this particular date, so that's why you can see in the lag column of fourth row we have 2018 0124. Conclusion: order date values are picked from 3 rows prior to current row due to offset 3, and within a window due to the partition by clause, and finally added one day to it due to the expression. So I hope you understood all the functionality of lag function and how you can use it in various situations. Now let's solve a particular question. So the question is, what is the percentage increase or decrease in current sale when compared with the previous sale amount for each salesman in central region? Percentage should be 2 decimal place. So for each salesman, you have to basically compare the current sale amount and previous sale amount and then find the percentage out of it. And the percentage should be in 2 decimal place. And like always, I would urge you to try this question on your own first, and when you come back, we'll take a look at the solution. So here is the solution to this question. First, I'm finding out the current sale as well as the previous sale value for each salesman in central region. So what is the query? Select star comma units into unit price. So that will give me the current sale value, and for previous sale I'm applying lag on the same units into unit price. Now I've given offset equal to 1, and if there is if there are no rows prior to record 1, then I'm giving default value equal to 0 over partition by salesman. Why? Because I have to find out this difference for each salesman. So I have to compare each salesman individually. Then I am ordering the order date in order to find out which sale came first and which sale came last. Finally, I am doing a filter on this region so that I can only get the data for central region as asked in the question. So as you can see, post running this query, I have current sale column generated and previous sale column generated. The current sale column is the multiplication of units and unit price, while the previous sale is the lag of this current sale basically. And if I just pick this particular window or this salesman, that is David. So as you can see, the first record, because it has no records prior to this, so default value, that is 0 assigned here. And then the second record gets the value of the first record, that is 6075. Similarly, the third record of previous sale has 23,000, which is equal to the second record's current sale. So this way I am able to find out the current and the previous sale value. So once I did this, the rest of the part is very easy. What I'll do is I will just subtract both of them and find the percentage out of it. So here you can see in the next command, I'm finding out the difference between current and previous sale. So the above query I have put inside a with clause. So this is a CTE or a common table expression. And using this, I can call whatever columns that I generated into another subquery. So here I've written that subquery where I'm selecting order date, region, salesman, item, units, unit price, and I'm selecting the current sale, that is this column, and previous sale, that is the lag column from my CTE that I developed, that is sales calc. And on top of that, I'm also generating the percentage column. What is that? That is current sale minus previous sale divided by previous sale multiplied by 100. So this gives me the percentage value. Then I'm doing a round off of 2 so that the decimal point does not go very much high and it looks good. And on top of that, if the previous sale is 0, that is this particular record, so anything divided by 0 gives us a null. For that I'm applying colis. So whenever a null value will occur, it will just assign current sales value to it. Let's take a look at the data now. So up till here we have seen in the previous record, in the previous command I mean. So this is the percentage difference. So as you can see, because previous sale was 0, by default the coolies will give the current sales value to it. But for the rest, we can see the percentage increase or decrease. Like so based on this record, this 23,000 is a 278.6% increase on the previous sale value. Similarly, this 63,000 is 176% increase on the previous value, that is 23,000. So this is our final result or the answer to the above question. So the next window function that we are going to discuss in this video is lead. So what is lead? The lead window function is exact opposite to lag function, because while lag returns for each row the value of the previous row, lead function will return the value of the following or the next row. So here is the syntax of lead, which is select star, lead column name, offset, then default, over partition by call 1, order by call 2 from table. So it is very similar to the lag function. Now column name is again the name of column or an expression. Offset is an integer number that tells how many number of rows after current row the value will be fetched. So in lag we used to pick the previous row. Basically if offset was 1 there, so we'll pick the previous 1 row behind the current row. But in lead, if the offset value is 1, then we will pick 1 row after the current row. Similarly, if offset value is 2, then we'll pick 2 rows after the current row. And the default, again it is similar to lag, a default value to assign if offset goes beyond the last row. Null is assigned if we don't define a default value. Example, if default is high and offset is 1, so for the last row lead will be high as there is no row after the last row. Let's check out an example now. So SQL lead function without default value. So here is my lead query, select star lead, and I'm applying lead on order date. Then there is no partition by at this moment, and I'm doing an ordering of the order date in ascending order and calling this column as lead. So the last row shows null value for lead column because it does not have any next row. Let's check that out. So as you can see, this is my last row and it has a null value because first of all I have not defined a default value and there are no rows after the last row, so by default it has null. The first row contains next row value in the lead column. It takes value from the next row due to default offset value is 1. So as you can see, inside the lead there is no offset parameter as well, so by default offset equal to 1 is set. Let's check out the first row's value. So as you can see, this is the first row. Now the lead column has the value of the second row's order date, that is 2018-01-23, and this value you can see here in the lead column. I hope this example is clear. Let's move on to another example. So the second one is SQL lead function with a default value. So this time, as you can see in this query, I have given offset equal to 1 and default value equal to 2000-01-01, and rest of the things are same. I'm applying lead on order date column and I'm ordering the order date column in ascending order. So this time the last row has default value instead of null. Let's check out the last row value now. So as you can see, the last row has the default value that we have defined inside the lead function. And similarly, the second row contains next row value in the lead column. It takes value from next row due to offset 1. So we discussed the record 1 in our previous example. Let's check out record 2 now. So as you can see, lead has value 2018-02-09, which is equal to third record's order date, basically this one. So I hope this is also clear. Now let's check out some more examples. So example number 3 is SQL lead function with offset value equal to 2. So I've written select star lead order date, and this time offset is equal to 2 and default value is 2000-01-01 over order by order date and in ascending order. So the last and second last row has default value instead of null because offset is 2 and there is no second row prior to it. So let's check that out. So as you can see, the last 2 rows have the default value, that is 2000-01-01. So there is no 2 rows prior to any of them. That's why the default value is picked. The first row contains third row's value in the lead column. It takes value from 2 row next to it. That's why third row's value was picked. So let's check this out as well. So as you can see, this is our first record, and here the lead value is picked from the third row, which is this one, 2018-0209, because I have set offset equal to 2. So 2 rows after the first row, the value will be picked. I hope this is clear. Let's move on to fourth example, which is SQL lead function with partition by clause. So up till now in the lead functions, I have not been using the partition by clause. So in this example, I've used that, and I'll explain you this. So I've written select star lead order date, and here offset is equal to 3. What does this mean? If we have a current row, then lead will pick 3 rows after that current row. Then the default value here I've given 2015-0101 over partition by region, order by order date, and that is in ascending, and the column name is lead. So what will happen? Using partition by clause, lead will pick value from next row within a window or a partition. Rest functionality remains same. Last and second last and third last row has default value instead of null. Why? Because offset is 3 and there is no third row prior to them. Let's check the last 3 values. So as you can see, because there is no third row prior to any of these, so we have the default value in the lead column. Finally, the first row contains 4th row's value in lead column. It takes value 3 rows prior to it. That's why 4th row's value was picked. Let's see that as well. So here is my first record, and as you can see, it has 2018-0418, which is the value of the 4th row's order date. So I hope you're understanding, like you're getting the basic understanding of how lead works and what will happen if we include partition by clause in the function, in the syntax. So let's check out the final example, which is using expression instead of column name. So expression works in a similar fashion which we saw in the lag function. So here I have written select star lead, then date add, and inside date add is my order date as well as 1. Basically I'm adding 1 day to the order date, and post that I've given offset equal to 2 and default equal to 2015-0101. Now here also I'm doing a partition by on region and order by on order date in ascending order, and the column name is lead. So what happens? The last and second last row has default value instead of null because offset is 2, and now we know why. There is no second row next to them. All the rows except the last 2 rows contains outcome of the expression. Expression is order date plus 1 day. Example, first row's value is 2018-0226 plus 1 day, which gives us 2018-0227. Plus, let's check that out. So this is our first record. First of all, because lead is applied, so the third or 2 rows after the first record, that value will be picked, which is 2018-0226. And as I've added here an expression which adds 1 day to the current date. So 1 day will be added to this date and the result will be returned into the lead column. Conclusion, order date values are picked from 2 rows next to current row due to offset equal to 2, and within a window due to partition by clause is applied, and finally added 1 day to it due to the expression. So I hope you got an idea of how you can apply expression as well as a column inside a lead function. So let's now move on to a question. So the question is, list down all the items whose units sold in current sale was more than the next sale. So we have to compare the current sales units with the next sales units that was sold, and whichever is more, the items of that sale we have to list down. So like the previous question, I will ask you to try this question out first, and once you come back, we will check out the solution. So in order to solve this question, first I have displayed the next units using the lead function. As you can see, I have written select order date, salesman, item, units, and then applied lead function on the units column over partition by item, order by order date. So if you check the question, it is list down all the items whose units sold in current sale was more than the next sale. So this difference or this comparison between current sale and next sale we have to do for all the items. So items is my window or my partition by clauses column, and for each item I am ordering the order date in ascending order to find out which sale is first and which sale is second. basically which is current and which is the next sale. So here is the data displayed. So let's just compare the records of our first window, that is cell phone. So as you can see, the first sale was on 2018 02/26 and the units are 27. The next sale on 2018 10/22 and the units are 64. In the next unit column, it consists of the next dates, next sales unit value, that is 64. Why? Because we have applied lead to it. So once we have done this for all the records, for all the products, then all we have to do is compare in which sale units are greater than next units. So that is what I have done. Using a subquery, I have compared the current sale units with the next units to find out which one is higher. So as you can see, I've written select order date, salesman, item, units, then I've applied lead on units, and outside, in the outside query, I've written select star from, and this is the inner query that I showed you above, and outside where x dot units is greater than x dot next units, and x is just an alias for this inner query. Once I display, you can see we have all those records where the sales of current unit is greater than the next sales unit. So as you can see, in this particular date, for salesman Alexander and for item cell phone, the current sale was greater than the next sale, and same goes for this record and all the other records. I hope you understood how to solve this question and how lead as well as how lag works, and that's it. So that's it for this video. If you found it useful, then please share it with your friends and like the video. In the coming few weeks, I have planned many such videos on PySpark and SQL interview questions. So stay tuned for them, and if you have not subscribed, then please press the subscribe button, and I'll see you next time.